Welcome to everyone to my channel Techify with Adil. So today in this video we will be discussing about the defense security system, Zero Trust model and defense in depth. So both the models are working expected to have a good defense system, and we will see how the both works and how it's been designed. So the Zero Trust security model assumes the worst case scenario and protects resources with the expectation. So Zero Trust assumes breach at the outset and then verifies each request as though it is originated from an uncontrolled network. So from the name says Zero Trust model, so it is always expecting a worst case scenario, like if it's what if it's from an uncontrolled network, or what if it's from an unaccessed or an high risk zone. So it will considering this as a scenarios, and the Zero Trust model has been built over that. So today organization need a new security model that effectively adapts to the complexity of the modern environment, embraces the mobile workforce, and protects people, devices, applications, and data wherever they are located. So to address this new world of computing, Microsoft highly recommends the Zero Trust security model, which is based on these guiding principles. So verify explicitly, always authenticate, and authorize based on all the available data points. This is the first guideline. The second is use least privilege access. So if you are going to if a person needs a particular access to maybe to read a blob, so like if you are giving a owner permission to the blob, also he can read. If you are giving a write permission, also he can read. If you are going to give a contributor or admin permissions, also he can read. But we must give them a least privilege access, so that he will be having a least privilege access, plus he will be able to do the task. So limit user access with just in time and just enough access. So just in time access and also just enough access. So this is the term of use least privilege access. So next is assume breach. So minimize base blast radius and segment access. So verify end-to-end encryption. Use analytics to get visibility, drive threat detection, and improve defenses. So we will be assuming there's a breach in the network. So have to do the analytics to have more visibility. So we should have run things to find there's a threat detections and improve the defenses based on the analytics and the threat defense detection reports. Then adjusting to Zero Trust. So traditionally corporate networks were restricted, protected, and generally assumed safe. So only managed computers could join the network, VPN access was tightly controlled, and also the personal devices were frequently restricted or blocked. So Zero Trust model flips the scenario. So instead of assuming that the device is safe because it's within the corporate network, it requires everyone to authenticate, then grants access based on authentication rather than the location. So just believing, since it's a managed device, or since it's the device is connected to the office network, just imagining or just believing that this device is safer, rather than doing that under the Zero Trust model. So even if it's located inside your network, even if it's a managed device, still it has to be authenticated, still it has to go through all the authentication processes, because that's how we can increase the security by this Zero Trust model. So here you can see, so the classic approach. So we just give a restriction to everything, like we have it. If it's like our office, then we have our database files and our computers, everything locked in it. So secured network, we are securing the network and believe that whatever inside our secure networks is all safer to use. But the other way, in the Zero Trust, protects access anywhere with the central policy. So it can be computer in our network or outside the secure network, or data inside or outside, whatever the scenario is, still you will have to go all through security checks to make sure the individual devices or individual data center servers or access is protected. The second model will be the defense in depth, the other model. So the objective of defense in depth is to protect information and prevent it from being stolen by those who aren't authorized to access it. A defense in depth strategy uses a series of mechanisms to slow the advance of an attack that aims to acquiring unauthorized access of data. So layer of defense in depth. So defense in depth works in the model of layer of defenses. So you can visualize the defense in depth as set of layers with the data to be secured at the center and all the other layers function to protect the central data layer. Each layer provides protection so that if one layer is breached, a subsequent layer is already in place to prevent the further exposure. So this approach removes reliance on any single layer of protection. It slows down an attack and provides alert information that the security team can act upon either automatically or manually. So you can see the picture here. So data is here. So if for the person, like for a hacker or the person who's breaching, you want access to data, he has to go through all these steps. He has to cross the physical layer, physical security, maybe a security person or agent, someone. Then he has to clear his identity and access. Then he has to clear the perimeter. Then he has to interfere into the network, then into the computing layer, then in access to the application. Only then he will be able to access the data. Once he is breaching any of this layer, then there will be an alarm already. So before he is able to breach all the other data, maybe the security team can take action on that. So the brief overview of the role in each layer. So physical layer is the first line of defense of protecting computing hardware in the data center. So the identity and access layer controls the access to the infrastructure and change control. So perimeter layer uses distributed denial of service, DDoS attack. So protection to filter large scale attacks before they can cause a denial of service for users. So the network layer limits communication between resources through segment and access control. Then the compute layer secures access to virtual machines, computing. An application layer helps ensure the applications are secure and free for security vulnerabilities. The data layer controls the access to business and customer data that you need to protect. These layers provide a guideline for you to help make security configurations decisions in all of your layers of the application. So in detail we'll be seeing about each layer here. So for the physical security layer, physical securing access to the building and controlling the access to the computing and the perimeter of the first line of defense. Then physical security, the intent is to provide physical safeguard against access to the assets. So these safeguards ensure that other layers can't be bypassed and loss or theft is handled appropriately. Microsoft uses various physical security mechanisms in their cloud centers. Then identity access layer is all about the ensuring that identities are secure, that access is granted only to what's needed, and the sign-in events and changes are logged. So at this layer, it's important to control access to infrastructure and change control, use single sign-on or multi-factor authentication, then audit events and changes. So even if a person who has access is accessing to some data, is making some changes, and everything should be logged and that has to be audited and checked. So perimeter. The network perimeter protects from network-based attacks against your resources, identifying these attacks, eliminating their impact, and alerting you when they happen are important ways to keep your network secure. At this layer, the important to DDoS protection to filter large-scale attacks, then perimeter firewall to identify and alert on malicious attacks against your network. Then network layer. At this layer, the focus is on limiting the network connectivity across all your resources to allow what's only required. By limiting the communication, you reduce the risk of an attack spreading to other systems in your network. So at this layer, the important is to limit communication between resources. Unwanted communication should be cut off. deny by default. So by default everything will be denied. Only you will create rules or permissions for required connections only, so that by that you will be very sure about what you have allowed. Then restrict inbound internet access and limit outbound access where appropriate. Only inbound connections, restrict the inbound connections from internet access. So anything from the internet to inside to our system should be restricted, and limit the outbound access where appropriate. Like we shouldn't open the outbound as well. It also has to be limited for only required connections. Then implement secure connectivity to on-premise network. The compute malware, unpatched systems, and improperly secured systems open your environment for attack. The focus in this layer is on making sure that your compute resources, say virtual machines, are secure, and that you have the proper control in place to minimize security issues. At this layer, it's important to secure access to the virtual machine, implement endpoint protection on devices, and keep the systems patched and current. Because if you're having a machine and you have control of all the other things, but the machine is unpatched, has a lot of malware or bugs in it, then it becomes vulnerable for the attack very easily. Then the application. So integrating security into the application development lifecycle helps reduce the number of vulnerabilities introduced in code. So every development team should ensure that its application are secure by default. At this layer, it's important to ensure all the application are secure and free for vulnerabilities. Store sensitive application secrets in a secure storage medium. Make security a design requirement for all application development. Then lastly, data. So those who store and control access to data are responsible for ensuring it's properly secured. Often regulatory requirements dictate the controls and processes that must be in place to ensure the confidentiality, integrity, availability of the data. So in almost all cases, the attackers are after data, obviously. So stored in the database, stored in disk inside the virtual machine, and SaaS applications or like M365 applications, then managed through cloud storage. So usually the attackers look for the data in all these locations. So it will be secured as in the defense in the different layer ways. The defense in depth model. The other model we see is zero trust. We assume there's a breach and work towards safeguarding the breach.